Something huge just happened in the AI and energy world, and it's sending shockwaves through both industries. Just when it looked like AI would devour massive amounts of electricity and drive energy stocks to record highs, a new player has stepped in and flipped the script. Meet DeepSeek R1, the model that has Wall Street panicking, AI giants scrambling, and energy companies questioning their billion-dollar strategies. But is the hype real? Is DeepSeek truly a game changer, or just another overhyped tech illusion? And what does it mean for the future of AI and energy? Buckle up, because we're diving deep into this tech showdown right now. Section 1. The AI energy boom. Let's rewind a little. Over the past few years, AI has been growing at an insane pace. Companies like OpenAI, Google, and Microsoft have been building larger and more powerful AI model zones that require huge amounts of computing power. That means more data centers, more chips, and most importantly, more electricity. This is why energy stocks exploded in 2024. The demand for electricity was projected to skyrocket as AI models required massive server farms just to function. Investors saw the trend and jumped in, driving energy stocks to all-time highs. Constellation Energy and Vistra, two major power companies, saw their shares go through the roof. And the industry wasn't just watching, it was acting. Constellation spent $16.4 billion to acquire Calpine Energy, betting big on AI's thirst for power. Tech giants like Google, Amazon, and Microsoft made their own deals, securing nuclear energy to power their AI ambitions. Everything seemed locked in place for an energy gold rush. And then, DeepSeek happened. Section 2. DeepSeek's disruption. Out of nowhere, a new AI model called DeepSeek R1 burst onto the scene and changed everything. Unlike OpenAI's massive models that need supercomputers and billion-dollar investments, DeepSeek's creators claimed they trained their model for just $6 million. That's not a typo, just $6 million. And they did it with fewer and less advanced chips. The result? Energy stocks plummeted. Investors panicked. If AI could suddenly run efficiently without consuming endless electricity, all those power deals and energy stock surges might have been for nothing. Section 3. Training versus inference. The real story. But before we start writing obituaries for the energy sector, let's break this down. How did DeepSeek pull this off? And is it really the AI energy cheat code that some are making it out to be? First, we need to understand the difference between training and inference. Training an AI model is the most energy-intensive part. It's where the AI learns by processing enormous data sets. This step usually requires tons of expensive chips and massive amounts of power. Traditionally, once a model is trained, running it is much less energy-consuming. But here's where DeepSeek flips the script. They found ways to make training cheaper and more efficient. They used smarter engineering, automation, and new reinforcement learning techniques that cut costs dramatically. That's why their training process was so much cheaper than competitors. Sounds great, right? Well, not so fast. Section 4. The hidden cost of reasoning models. Here's the twist that most people missed. DeepSeek isn't just another AI model. It's a reasoning model. Reasoning models don't just spit out text based on patterns. They actually think through problems, breaking them down into logical steps. They test different solutions, learn from their mistakes, and improve their answers dynamically. In theory, this makes them way smarter, especially for complex tasks like coding and math. But there's a catch. Reasoning takes energy. A direct test showed that DeepSeek R1 actually used 87% more power than Meta's Llama 3.3 model when answering the same set of questions. Why? Because it doesn't just generate an answer, instantly runs multiple computations in the background, evaluating different possibilities before picking the best one. Section 5. What this means for AI and energy. So, what does this all mean? Did DeepSeek really break AI's dependence on energy, or did it just shift the demand in a different way? Here's the reality. While DeepSeek made AI training more efficient, its inference stage is actually more power-hungry than traditional AI models. That means, instead of data centers using massive energy up front, we might just see ongoing high-energy consumption as these reasoning models run 24/7. In other words, the energy revolution some expected might not be happening at all. we might still need all those nuclear deals, all those power grid upgrades, and all those AI data centers. The market's panic may have been a massive overreaction. DeepSeek's breakthrough is real, but it doesn't eliminate AI's energy demands. Instead, it shifts them into a new form, where running AI might become just as energy-intensive as training it.